let's tune the telescope in to galaxies being born. And oh my gosh, who ordered this? We're finding galaxies in the dark ages.
However, when we look at the size and shape of the galaxies observed by the JWST, they paint a reality that seems completely at odds with what we've long believed under the Big Bang theory. Instead of tiny galaxies growing and merging into the massive galaxies we see today, these galaxies appear fully formed and organized from the start. The process of galaxy formation is often compared to toy cars that collide and merge, gradually growing in size, starting as a small car and eventually becoming a full-sized SUV. According to this analogy, if galaxies grew through collisions and mergers, we would expect to see evidence of these collisions or dents in their structure. However, observations made by the James Webb Space Telescope, JWST, cast doubt on this merger theory. If the toy car analogy were accurate, we would see clear signs of interaction between galaxies, but these aren't as evident as expected. So, does this mean the Big Bang theory is just a convenient story? Not exactly. The theory is supported by strong evidence. For instance, the redshift of light from distant galaxies shows that the universe is expanding. This redshift, along with the fact that galaxies are moving away from each other in all directions, supports the idea that the universe is continuously expanding, just as the Big Bang theory predicts. The abundance of light elements like hydrogen and helium across the cosmos also aligns with predictions from the theory. Moreover, large-scale astronomical surveys reveal a distribution of galaxies that fits the patterns expected from the Big Bang theory. One of the most compelling pieces of evidence for this theory is the discovery of the cosmic microwave background, CMB, which is faint radiation that permeates the universe, acting as the afterglow of the Big Bang. First detected in 1965, the CMB has been extensively studied, and its characteristics, such as its uniformity and temperature distribution, closely match the predictions made by the Big Bang theory. The presence of this radiation suggests that the universe was once in an extremely hot, dense state before expanding, as the theory proposes. The CMB provides a remarkable glimpse into the early universe and is often regarded as a direct echo of the moments following the Big Bang. Its discovery has played a key role in solidifying the Big Bang theory as the leading explanation for the origins of the cosmos. However, new observations, like those from JWST, challenge parts of this theory. The detection of galaxies with ages that seemingly predate the Big Bang calls into question the theory's fundamental premise that the universe began with a singular event. Proponents of the Big Bang theory expected that as we looked further back in time, we would see fewer galaxies, eventually reaching a period known as the Cosmic Dark Ages. Yet, the abundance of galaxies observed by JWST challenges this expectation, suggesting that our understanding of the universe's origins might need to be re-evaluated. There should theoretically be a point in time when nothing existed at all. However, recent research suggests that even just a few 100 million years after the supposed Big Bang, galaxies as massive as the Milky Way were already common. According to the study's authors, the James Webb Space Telescope, JWST, images reveal at least 100,000 times more galaxies at redshifts greater than 10 than originally predicted by theorists. The sheer number of these large galaxies appearing so soon after the Big Bang challenges the plausibility of the theory. What's even more striking is that, according to current scientific literature, the Big Bang theory is associated with 16 incorrect predictions and only one accurate one, regarding the abundance of deuterium, an isotope of hydrogen. This isn't a promising track record. Additionally, the theory's predictions about the abundance of helium are off by a factor of 2, while its estimates for lithium abundance are off by a factor of 20, a massive error. But it doesn't stop there. The theory also struggles to explain various phenomena, such as the absence of the anticipated optical illusion where distant objects should appear smaller as they get farther away. This is alarming because large-scale structures exist in the universe that should not have had enough time to form since the Big Bang. Moreover, predictions regarding the density of matter and observed asymmetries in the cosmic microwave background don't align with theoretical expectations. As mentioned earlier, the age and abundance of galaxies revealed by the JWST also cast doubt on the Big Bang theory. The telescope uses infrared filters to capture images of distant galaxies, enabling astronomers to analyze the colors and estimate the age of the stars. Hot, young stars emit blue light, while older, cooler stars, like our Sun, emit yellow or red light. This color information helps astronomers determine a star's age. More massive stars burn out quickly, living only a few million years, while less massive stars can last billions of years. According to the Big Bang theory, the most distant galaxies seen by the JWST should show the universe as it was around 400 to 500 million years after the event. However, some of these galaxies display stellar populations that are already over a billion years old, creating a major issue for the theory. If the Big Bang were the origin of everything, nothing should have existed before it. These findings are just a few examples of the growing contradictions that challenge the validity of the Big Bang theory. Despite these significant inconsistencies, it's intriguing that the collapse of the Big Bang theory hasn't been widely acknowledged by major media outlets. With something this monumental, you'd expect widespread coverage and debate across news and social media. But instead, there's been virtually no attention. This silence could be attributed to the "emperor's new clothes" effect, where questioning the Big Bang theory can result in scientists being labeled as unintelligent or unqualified. It's a classic case of if you don't grasp this basic concept, why are you even here? A few years ago, researchers who could fund their own cosmology projects had some freedom to publish alternative views, but those papers were often dismissed by the mainstream cosmological community. As the crisis within cosmology became evident in 2019, the established cosmological community rallied to defend the Big Bang theory, often resorting to censorship due to a lack of alternative defenses. Compounding the issue is the fact that funding for cosmology research largely comes from a limited number of government sources controlled by committees dominated by Big Bang theory supporters. In such an environment, those who challenge the theory struggle to secure funding for their research, even if it's unrelated to the Big Bang. This lack of support not only stifles progress on alternative theories but also prevents meaningful exploration of the theory's flaws. It has become increasingly difficult to publish papers critical of the Big Bang theory in astronomical journals. So even if someone challenges it, their work may never see the light of day. This situation brings us to a crossroads. If the Big Bang theory isn't accurate, how did the universe form? Surprisingly, there are other theories that might explain it. One such concept is eternal inflation, which suggests that our universe is just one component of a much larger multiverse, a concept we've become familiar with thanks to pop culture. While pop culture often adds flair to scientific ideas, the core idea of the multiverse is that it consists of many bubble universes, each with its own unique set of physical laws and properties. Another alternative is the steady-state theory, which proposes that the universe is in a constant, unchanging state and has always existed. Unlike the Big Bang theory, which posits a specific beginning, the steady-state theory suggests that the universe has no origin point and will continue to exist indefinitely. A key aspect of this theory is the idea of continuous creation, where new matter is constantly generated to fill the gaps created by the expanding universe. There's also the cyclic universe model, which combines elements of both the Big Bang and steady-state theories. According to this model, the universe undergoes a series of repetitive cycles. Each cycle begins with a Big Bang, marking the birth of a new universe, and ends with a Big Crunch, where the universe collapses back into a dense, hot state. Interestingly, this cyclic universe model could potentially explain the newly detected galaxies, suggesting that they might belong to a new cosmic cycle we've just observed. Could this offer the definitive evidence needed to challenge or even disprove the Big Bang theory? It's certainly a fascinating possibility.